Hey guys, welcome back to CCL Biology, the channel for easy to understand biology lessons. If you need some extra help with your general or AP biology class or even a college biology course, this is the place for you. I am your friendly bio nerd. Thank you so much for tuning in to my channel. In this video, I'm going to be talking about ionic compounds. So if you want to get a better understanding of ionic compounds, then stay tuned. While you're here, don't forget to hit the like button below if you find this video to be helpful. And if you want more easy to understand biology lessons, then be sure to subscribe to my channel and click the notification bell to be notified about new videos that go up every week. Okay, as I said, this video is about ionic compounds. And this is a follow-up to my video about ions, so I will post that link in the description box below. In that video, I talk about what ions are, how they're formed, and how they use ionic bonds to join with other ions. So here, I just want to tie things together by actually talking about ionic compounds. Now, an ionic compound is a compound that's formed with ionic bonds. These bonds are formed by an attraction between a metal and a nonmetal. For instance, sodium and chloride ions. Now here, if we look at the periodic table, we see that sodium is an alkali metal and chlorine is a halogen nonmetal. Now we know sodium chloride as table salt, and ionic compounds are commonly referred to as salt. So that means sodium chloride is not the only salt that exists. We also have potassium bromide, lithium fluoride, magnesium oxide, and many other salts. If we have a metal and a nonmetal ion coming together in an ionic bond, the compound that results is considered a salt. Now, ions exist as cations, which means that they have a positive charge, or as anions, which means they have a negative charge. I talk more about cations and anions in that ions video, but again, to bring it together here, salts or ionic compounds are going to contain cations and anions. So table salts, NaCl, sodium chloride, has sodium cations and chloride anions. So let's just take a look at this picture here. I have the sodium ion and the chloride ion. So the sodium ion has 11 protons, which aren't illustrated here in this picture, and 10 electrons, which are illustrated by the red circles. So because the sodium ion has more protons than it does electrons, that means it's going to have one extra positive charge, which is going to make it a positively charged ion or a cation. The chloride ion has 17 protons, again not pictured, and 18 electrons represented by the red and purple circles. So this ion has fewer protons. It has more electrons than it does protons. So that's going to give the ion an extra negative charge, which makes it an anion. When salts are formed in nature, they typically take the form of a crystal. Now, the size and shape of the crystal is nowhere near consistent from one salt to another. It can be a big crystal or a small crystal. It may have a defined shape or it may not. So because of this, as you can see here in these illustrations, we can't count the number of ions in any one salt compound. Now that's one difference between ionic compounds and molecules. We can count molecules. Now with ionic compounds, we only know that there are a bunch of cations and anions that came together with ionic bonds and formed a crystal structure. But another thing we can figure out is the ratio of the ions, and we can do that based on the chemical formula. Now that may sound a little scary, but it's not. If you are taking chemistry or if you have taken chemistry, then you probably already know how to write out a chemical formula for an ion. And if you haven't, you can still look at the formula to figure out the ratio of cations to anions. So let's look back at sodium chloride. Now what we're looking for to give us the ratio are small little numbers written down at the bottom of the formula next to the ion that it's referring to. So typically you'll see like little small number 2, number 3, or no number at all. Now if there's no number written, then that means that there is one of that particular ion in the formula. So 1 is represented by no number. So in this case here, we see NaCl, which is the chemical formula for sodium chloride, has no numbers, which means that there is one sodium ion and one chloride ion in this formula. So this gives us our ratio. So if we were to pick up a crystal of sodium chloride, and this illustration here is a 3D representation of a sodium chloride crystal. If we were to have this in our hands, we would not be able to count how many individual sodium chloride couples there are in this crystal, but we will be able to know the ratio. The ratio is going to be 1 to 1. So that means that for every one sodium ion, there is one chloride ion. Now let's look at another ion. How about calcium chloride? Now the formula for this ionic compound is CaCl2. So that means that for every one calcium ion, there are going to be two chloride ions. Okay, now this part may be a little tricky, so go back over it if you need to. Now, remember I said earlier that ionic compounds are not the same thing as molecules, but an ionic compound can have a molecule in it. Now, what does that mean? Take ammonia, for example. So here we have ammonia, and this is a molecule, and it has one nitrogen atom, as you see here represented with the N, and 3 hydrogen atoms represented by the 3 H's. But sometimes an extra hydrogen comes along and sticks its singular proton onto that nitrogen. Now that'll give us 1 nitrogen and 4 hydrogen atoms. And that's going to give us a charge of +1, because now we're going to have more protons than electrons. So if we look here, I don't have the protons and electrons pictured, but we have the NH4 is now going to have 11 protons while it has 10 electrons. All right, so that's going to give it a +1 charge. Now, as I said in my ions video, an ion is just an atom or a molecule with a charge. So because that ammonia molecule now has a charge, it has become an ion, and now its name is ammonium. Now, just like any other cation, an ammonium ion can bond to an anion through an ionic bond. For instance, a chloride anion, and with that it can form an ionic compound like ammonium chloride, like we see here. Now, ionic bonds are strong when the ionic compound is dry, although it's not going to be as strong as a covalent bond. But if an ionic compound is placed in water, then that ionic bond is going to become much weaker. This is because the ions, which are polar, are going to dissociate or separate from each other in the water, because water is also polar. So for more information about that, be sure to check out my video, 5 Great Things About Water, where I talk about water as a universal solvent. But just getting back here, so if we look here in this picture with this container of water, we see these pluses and negatives. So these are representing cations, positive ions, and anions, or negative ions, from an ionic compound that has been placed in water. So once that compound was placed in the water, the cations and anions dissociated from each other. They began to break apart as the polar water with the positive hydrogen and the negative oxygen started to pull and tug on those ions and separate them from each other. So here's another example here. We see a crystal structure of sodium chloride, or table salt. So this would be an illustration of the crystal when it's dry. So you see it's still well put together, well organized. But once the sodium chloride hits the water, notice now how the ions have dissociated from each other. And this kind of gives a better picture, because here we can see the water molecule as well. So we see the H2O, the reds represent the oxygens, and the grays represent the hydrogens. And just to keep up with the NaCl, the green is the chloride ions, and the purple is the sodium ions. So you can see how here we have the positive sodium ion. See how it is close to this negative oxygen region of the water molecule. On the other hand, the negative chloride ion here is oriented toward the positive hydrogen regions of the molecule. So that's what happens when an ionic compound is placed in water. The ion bonds will break and the ions will dissociate from each other as they become attracted to the polar water molecule. So this actually works out pretty well for medications. A lot of medications are made in salt form. And the reason for that is because it's going to stay intact. The medication is going to stay intact as long as it's dry. So once it's placed in that dry container and packaged and shipped, then it stays intact. But once someone takes the medication and it goes down into their body, then it's going to break apart, which is exactly what we would want the medication to do. Well, that's it for today's video. I hope it was helpful for you. If so, then please leave a thumbs up in the comment section below. And if you have any remaining questions, definitely type those in the comments and I will do my best to provide you with an answer. Thanks again so much for watching CCL Biology, that is Christ-Centered Life Biology. God bless and bye-bye.